All right, let's take a look at our lesson for today. So what we're going to be looking at today is L'Hopital. Yay! Um, so this is a technique that a mathematician, and that's was his last name, L'Hopital, came up with, which was really actually pretty cool. I don't know how he came up with it. How many limits would he have had to done? I don't even know. But this rule works if we have a limit in the form of 0 over 0 or infinity over infinity. Now, if you recall, before learning this, what did we need to do? When we got a limit in this form, what was our next step? Keep going. We want to keep going, right? And you could still do that. But what this allows us to do, it allows us another way. This is another way to solve a limit that's 0 over 0 or infinity over infinity. And that is this technique right here. So what did he do? Here's the limit, and it's in that form. You know, if you plug in this value for x, you're going to get 0 over 0, infinity over infinity. What he figured out was that if he, now this is not a quotient rule, if he took the derivative of the numerator and then he took the derivative of the denominator and tried the limit again, it would work. Many times it would work. Sometimes there are other things we need to do, but it'll work. In other words, you won't get 0 over 0 or infinity over infinity. You'll actually get a number. Okay, so it's actually pretty cool. Before we get into this, I want to explain, so that's the rule that we're learning today, but I do want to explain that there are several, I call them levels, several levels of L'Hopital. This level one, it's just something I call, this is level one. Level one are these types of indeterminate forms. They're 0 over 0 or infinity over infinity. And we just use this rule. We just use L'Hopital. Okay, that's basic, straightforward. And most of our work will be in that. We also have something I call level 2. And these indeterminate forms are infinity minus infinity or 0 times positive or negative infinity. When we have these kind of indeterminate forms, our go-to would be to rewrite. We would rewrite. Rewrite so it looks like a level 1. That's what we would do. Rewrite. And we are likely to come across this kind where we have to rewrite. It is likely that we will come across it. So let's talk about the ways that we would rewrite. So for this kind, typically the way that we would rewrite would be to find a common denominator. Many times that fixes the issue and then it puts it back into a 0 over 0 or infinity over infinity situation. For this kind, where it's 0 times positive or negative infinity, for this kind, we would, there's a couple of different things we could try. One is we could try trig identities. That's a pretty good way to rewrite, and a lot of times that fixes our problem. And the second way is flip the x upside down. And I'm going to give you an example of that, which means turn into a complex fraction. Okay, and I'm totally making this up, so this is not an indeterminate. I'm just making up the concept. So let's just pretend that it's x times, I don't know, I'm just going to make up something, e to the x, whatever, x times e to the x. So what I would do is I would take that x, I would rewrite it so that it would be e to the x over 1 over x. See how I took the x and I flipped it upside down to make it improper? So many times that technique, and again, I made up the limit, so this isn't one of these, but that technique would help us to get a level 2 into a level 1. Okay, so that is level 1, level 2, and I know you're probably just like anticipating, is there a level 3? Yes, there is. There is a level 3, which are the most fun, and I hate to tell you, but we don't have time to do level 3s. I know, it's such a bummer, right? But a level 3 are these types of indeterminate forms, like infinity to 0, like 1 to infinity, and there's another one I can't think of off the top of my head. So these are really serious business.
In the rewrite, so it looks like, what is the word after the word?
Level 1. So it looks like level 1. We want them to look like level 1. That's what we want, because those are the straightforward ones. So I will tell you, for level 3, we will encounter some level 3s, but only using a formula. We're not going to have to do these from scratch, although it is super fun. And the formula that we're going to use is actually on your formula chart. I put them up here. These are the formulas that we would use on a level 3. And I'm going to explain how those formulas work. Okay, so on this one, notice if I substitute in, is everybody okay? Are we all good? Yes. I substitute in, like this is positive or negative infinity. What happens to this fraction? This fraction would go to 0, right? So then I would have 1 to infinity. That's what this kind is. This is a 1 to infinity formula. And it has to look just like this, and you know it will. Okay, this one, I sub in a 0, and I get, what do I get? Put a 0 here and a 0. So this would be 0. That would be 1 to, well, 1 to infinity. Okay, same scenario. So let me explain how the formula works. So I'm just going to give you an example. Let's say we've got the limit as x goes to infinity of 1, and that first has to be a 1. Otherwise, you'd have to do level 3 by hand. 1 plus, and let's say we've got to have an x there. We have to have an x here. But these 3 places could have a number in them. Those 3 places could have a number in them. Okay? And so I'm just going to make up some numbers to put in there, and I'm going to show you how it affects our answer. So our answer is e to the c. Right? That's our answer. So let's just say the number, I don't know, let's put a 3 there, a 2 there, and a 4 there. Let's just put those numbers. So how does that affect our answer? That's our question. Again, we just memorized the formula. So our answer is e to something. So the way that it works is that these 2 numbers are multipliers. So that would be 2 times 4, or 8. And this number is one that would be like a divider. That would be dividing. So my answer would be e to the 8/3. And that's really all we need to know how to do for level 3s, is use those 2 formulas, which are on our formula chart. Okay, so that's the overview of L'Hopital and how we will encounter them. Now what I would like to do is just to go through and work those 3 examples. Let's work the 3 examples and see how it plays out. All right, so are we okay with this? All right, so let's go to our first example. So in looking at this, I'm just going to put like, so e to the 0 is 1, 1 minus 1. Okay, so this is 0 over 0. So in past times, we were allowed to just arrow 0 over 0 and be fine, but not anymore. What we have to do is we have to specifically call out the numerator and denominator separately. So in order to use L'Hopital, you have to do this step that I'm getting ready to show you. If you don't do this step, you cannot use L'Hopital. And this is the step. You would say the limit as x goes to 0 of e to the x minus 1 of our numerator, that is 0. You can't put a fraction bar. Don't do that. Then, in fact, I'm not even going to put them together. The limit as x goes to 0 of our denominator, which is x cubed, is 0. So these two pieces are required in order for you to be eligible to use L'Hopital. I just need to make that clear. You cannot use L'Hopital unless you do the limit of the numerator to 0 and the limit of the denominator to 0, period. Now, once we have that, then what I would like for you to do is to write LH on your paper so that I know you're using L'Hopital. I would just like you to write that there for me. So here we go. So we're using L'Hopital. So the limit as x goes to 0. Now I take, and this is not quotient rule, I take the derivative of the numerator. The derivative of e to the x is e to the x. The derivative of 1 is 0. Okay. In the denominator, the derivative of x cubed is 3x squared. And then I sub in a 0 again. And I get, let's see, e to the 0 is 1. And then that is 0. Now let's think back to our work with limits. What does it mean when we get a number over 0? That we're either going to positive or negative infinity or a combo, right? That's what it means. So let's investigate. If you recall, we do like a, I'm going to think about it as a number line. This would be 0. So remember, we go 1/10 on either side. So 0.1, negative 0.1. Remember that, where we investigate whether we're going to positive or negative infinity? This denominator, x is squared. Is it possible for the denominator to be negative ever? No. Is it possible for e to the x to be negative ever? No. So whether I put in a negative 0.1 or a positive 0.1, I'm going to get a positive answer, correct? So this one is tending to a positive infinity. And then we would just say positive infinity and box our answer. Okay, we're not going to say equal infinity because you can't equal a concept like that. All right, questions on our very first one. Okay, let's do the second one. So on the second one, let's investigate this. So cosine of 0 is 1, 1 minus 1. So I got 0 over 0 business going on again. So here we go. In order to use L'Hopital, we're going to do the limit as x goes to 0 of the numerator. And 1 minus 1 is 0. And then we're going to do the limit as x goes to 0 of the denominator, which is 0. Notice I'm not making them a fraction. Don't make them a fraction. But again, this is required for us to do L'Hopital. Okay, so I'm going to put my little LH out to the side. I'm doing L'Hopital. And so we've got the limit as x goes to 0. So the derivative of 1 is 0. The derivative of negative cosine is a positive sign. The derivative of x squared is 2x. And if I simply put in 0 again, I'd have sine 0 over 0, which is, 0 over 0. Or I could think, so it's eligible for L'Hopital. And I am going to do L'Hopital one more time just to show you. But also we actually know something that will solve that, don't we? Don't we know the special limit? The limit as x goes to 0 of sine x over x. What is that? 1, this would be 1 times a half or a half, right? So our answer is a half. But I do want to do L'Hopital one more time just to show you that we could do it that way if we wanted to. So we would show the limit as x goes to 0 of sine x is 0. We would show the limit as x goes to 0 of 2x is 0. So this is the requirement of doing L'Hopital. This is my second venture at L'Hopital. So here we go. The limit as x goes to 0. The derivative of sine is cosine. And the derivative of 2x is 2. So I sub in a 0. Cosine of 0 is 1, and I get 1/2. So either way I did it, whether I use that special rule that we've memorized, a special limit, or whether I do L'Hopital again, I should get the same answer. All right, questions on that? And you certainly are welcome to use that special limit if you didn't want to do L'Hopital again. All right, last one. So here, the limit as x goes to 0 from the right of natural log and cosecant. To be honest, I would need to graph those. That's how I would do it. I don't have it memorized. So I'm going to go out here to the side and think about this. I'm going to graph this. Natural log looks like that, right? So as I'm headed to 0 from the right, that's going to go to -infinity, right? Cosecant is the reciprocal of sine, so I'm going to draw my shadow sign. And cosecant would be like, that's how I draw the graph for cosecant, is put the shadow sign and then flip it upside down. I mean, this would be cosecant. And I can see that coming from the right, that one is tending to infinity. So we've got like an infinity over infinity situation going on. Of course, we're not going to say equal, and we're not going to put a line between them. Now we're going to do the requirement to be able to use L'Hopital, which is the limit as x goes to 0 from the right of natural log. We're tending to -infinity. Okay, don't put equals. And the limit as x goes to 0 from the right of cosecant x tends to positive infinity. So therefore, I can do L'Hopital. So again, this is my requirement. I have to write those to do L'Hopital. So here we go. And I'm going to write LH so that you and I both know what we're doing. All right, the limit as x goes to 0 from the right. So the derivative of natural log is 1 over x. The derivative of cosecant is negative cosecant cotangent. I still have an infinity over infinity business going on. And I hope you can see that it doesn't matter how many times I do L'Hopital, it's not going to get any better, right? If I took the derivative of the numerator, I'd get -1 over x squared. Is that going to be any better? No. If I do the derivative of the denominator, I'm going to have to do a product rule. Oh, it's just going to get worse and worse. So what I would do here is I would stop and I would rewrite. I would keep going. Because this is like an infinity over infinity business. I'm going to keep going. I'm going to rewrite. I can't really do much with the 1 over x, but I certainly can change the way cosecant and cotangent look. So let's just do a rewrite. So the limit as x goes to 0 from the right. So I got a 1 over x and then over that. So let's see. Cosecant is 1 over sine. And cotangent is cosine over sine. Okay, so we're making some changes. So the limit as x goes to 0 from the right, I've got the 1 over x over, let's see, negative cosine over sine squared. Okay. That's a little bit more compact. I don't like the complex fraction, so I'm going to fix it doing our keep, change, flip business. Remember that? Keep the numerator, change the division to multiplication, and flip the denominator that you probably learned in, I don't know, middle school or elementary school. So we've got, so I keep the numerator, I change division to multiplication, and I'm going to flip the denominator upside down. So sine squared x over cosine, negative cosine. What I would do is I would try to utilize my special limit of sine x over x. I'm going to rewrite this into two limits. The limit as x goes to 0 of sine x over x times the limit as x goes to 0 of, what do we have left? We've got sine x over cosine x, negative cosine x. Okay, so remember, why can I do that? This isn't bad algebra. All those things are being multiplied together, and we know that we can multiply in any order that we want, right? Is everybody okay with that? So I know this is the special limit, and that is going to give me a 1. When I substitute a 0 in for sine of 0 is 0, and cosine of 0 is 1. So what that does is that gives me actually 0 as my answer. All right, how are we doing?